For many years after the Apollo and Luna missions, the secrets of the moon remained shrouded beneath its gray dust, while humanity shifted its attention toward distant planets and stars. When the Soviet Union brought back its last batch of lunar samples in 1976, it signaled the closing of one chapter. Then, almost without warning, a renewed lunar rivalry ignited. Brand new SpaceX rockets thundered off their launch pads. NASA introduced the ambitious Artemis initiative, and China quietly embarked on journeys into uncharted lunar realms. Rumors began to swirl about odd findings hidden on the moon's far side. What exactly was discovered beneath that ancient regolith, and why has there been a sudden rush to return?
The story of lunar exploration. To set the stage, let us look at the broader picture. China's quest to explore the moon began only in the early 2000s, unfolding through a carefully crafted, stepwise plan. The China National Space Administration, or CNSA, launched a fleet of Chang'e orbiters and landers, all named for the legendary moon goddess, with the aim of systematically studying our closest neighbor in the cosmos. Their efforts blended scientific curiosity with strategic intent, paving the way for China's rise as a powerful spacefaring nation. Chang'e 1, launched in 2007, represented China's very first lunar orbiter. It assembled a three-dimensional map of the moon's surface and analyzed the composition of its soils. Among its most remarkable findings, Chang'e 1 sensors picked up the presence of helium-3 in the lunar regolith, a tantalizing clue hinting at China's interest in harnessing extraterrestrial resources. Another orbiter followed in 2010, this time equipped with sharper cameras. Chang'e 2 scouted potential landing zones for upcoming missions, swooping just 9 miles above the rugged surface to capture detailed images and assess the safety of each location.
In just 3 short years, China achieved a major breakthrough. It executed its first soft landing on the moon. The spacecraft touched down gently on the near side, in the Mare Imbrium region, and deployed the U-2 rover. This marked the world's inaugural lunar landing since 1976, breaking more than 3 decades of silence. The U-2 rover explored the desolate plains, carrying an ultraviolet telescope, the first of its kind ever deployed on the moon's surface.
2019 saw the launch of Chang'e 4, a mission destined to rewrite lunar history. Originally designed as a backup for Chang'e 3, it was reassigned to venture to the mysterious far side of the moon. Its mission? To become the first spacecraft in human history to make a controlled landing on the side eternally hidden from Earth. No other nation had ever accomplished such a feat. China's disciplined, step-by-step approach displayed not only technical expertise, but also a clear geopolitical ambition. Overseen closely by CNSA and the nation's military, China's lunar program pursued twin goals: expanding scientific knowledge and bolstering national prestige. Some experts believe China's true motivation lies in the hunt for strategic resources, hinting at the dawn of a renewed race for lunar energy. Beyond mere national pride, the real prize may be the untapped reserves of metals, water, and nuclear materials scattered across the moon. So, on the 3rd of January, 2019, Chang'e 4 descended into the perpetual darkness of the moon's far side, settling softly in the von Karman crater. This ancient crater lies within the immense South Pole Aitken Basin, one of the largest impact scars known anywhere in the solar system. The far side's importance is immense. Forever turned away from Earth, shielded from our constant radio noise, it remained a blank spot on the map for previous missions. Scientists had long dreamed of exploring its pristine landscapes and radio-quiet environment, but overcoming the technical barriers seemed a monumental task. Because the solid bulk of the moon blocks any direct signals, no probe on the far side can communicate with Earth without a relay in place. China introduced a clever solution, a dedicated satellite called Quaikao, or Magpie Bridge. In May 2018, Quaikao took position at the Earth-Moon L2 point, hovering beyond the moon so it always maintained sight of both Earth and the hidden lunar hemisphere. This communications bridge was vital. As Chang'e 4 neared the surface, all commands were channeled through Quaikao. Seconds after landing, the probe reported back to mission control using this link. Still, the landing zone itself remained enveloped in total radio silence, a perfect setting for groundbreaking experiments. There, Chang'e 4 deployed its Yutu-2 rover, which rolled down onto the ashen soil 12 hours after touchdown. This marked a momentous first for humanity and a remarkable feat in the annals of lunar exploration. NASA Administrator Jim Bridenstine, celebrated American scientist, commended this remarkable achievement with genuine enthusiasm. From the shadowed far side, the cameras of Yutu-2 captured vistas that no human had ever observed so intimately before. There lay a battered expanse beneath an endless black sky, a landscape utterly foreign to human eyes. The geological mysteries of this far hemisphere fascinated scientists, for unlike the near side, it lacked vast stretches of dark volcanic plains. Instead, a thicker lunar crust, scarred by countless craters, defined its surface. By probing these enigmatic features, the mission promised to finally shed light on a puzzle that had baffled experts for generations. Why do the two sides of the moon differ so radically in appearance and composition? Chinese missions soon set about unearthing, or more accurately, unveiling a wealth of discoveries. These ranged from rare and unfamiliar substances to tantalizing clues about resources that might one day fuel human settlements among the stars. The findings did more than stir curiosity, they began to unravel mysteries that had persisted for decades. Chief among these was the prized isotope helium-3, a rare treasure woven into the lunar dust, and a resource that has captured the imagination of scientists everywhere. While scarcely present on Earth, helium-3 is plentiful in the moon's soil, having been deposited over millennia by the solar wind. In theory, helium-3 could revolutionize energy production, providing clean power on an unprecedented scale through nuclear fusion. Chinese researchers highlighted this extraordinary potential. In the year 2020, the Chang'e 5 mission returned with samples from which a new mineral was identified at a site named Chang'e Site Y, a location containing unmistakable traces of helium-3. The prospect dazzled scientists. Just 1.4 ounces of helium-3 could yield as much energy as 5,000 tons of coal. Some experts estimate that the lunar regolith holds more than 1 million tons of this invaluable material, enough to meet Earth's energy needs for thousands of years. From the outset, Chinese lunar orbiters and rovers have been systematically charting the spread of helium-3 and analyzing lunar soil to locate the richest deposits. This extraordinary gas may well ignite a new gold rush on the moon, and the Chang'e missions are at the forefront, prospecting the most promising sites.
Yet not every discovery followed expectations. In the middle of 2019, controllers operating Yutu-2 detected something peculiar inside a modest crater, a glistening, textured patch unlike the surrounding dust. News of the so-called mystery gel set the internet abuzz. What could possibly be sticky or fluid on the airless lunar surface? Was it volcanic glass, the melt from a meteorite, or something even more unusual? At first, Chinese officials withheld photographs, amplifying speculation. When images finally emerged, they revealed a lustrous, dark substance nestled among the rocks and dust. Scientists analyzing its spectral signature concluded it was breccia, soil and fragmented rock fused together by the intense heat of a meteorite's impact. In essence, it was a patch of sleek, glassy lunar rock, likely rich in minerals such as olivine and pyroxene that had melted into a smooth mass. Not quite alien ooze, but nonetheless a find that sparked excitement.
This shiny patch bore a striking resemblance to the melted regolith gathered by Apollo astronauts, yet it was discovered in uncharted territory. It told the silent tale of the powerful collisions that have sculpted the moon's hidden face. Amid all these developments, Chang'e 4 also transported a miniature ecosystem experiment, a sealed vessel about the size of a bucket packed with soil, seeds, and insect eggs. In January of 2019, researchers announced a groundbreaking achievement. A cottonseed had sprouted within this container right on the surface of the moon. The world saw the photograph, a fragile green shoot unfurling under lunar gravity, marking the first time a plant had grown beyond the confines of Earth. This offered a symbolic preview of future lunar greenhouses. Sadly, the tiny plant's life was brief. Merely 2 weeks after landing, lunar night descended, and temperatures inside the vessel plunged to minus 62 degrees Fahrenheit. Without sunlight, and after the heater ceased, the seedling perished as scientists had anticipated. Nevertheless, during its fleeting existence, this experiment proved that life from Earth could take root, even in the most distant and alien environments. Additional seeds, such as potatoes, as well as fruit fly eggs and yeast, found their place inside the biosphere in hopes of nurturing a miniature ecosystem. Though none managed to hatch or sprout before the freezing temperature set in, this undertaking represented a momentous leap forward in the field of astrobiology. It proved that astronauts might one day cultivate crops on the lunar surface, a crucial step on the journey to establishing enduring bases on the moon. As one researcher described it, this marked the very first occasion humans carried out experiments in biological growth directly on the moon. A single small green leaf set against the barren gray landscape became a profound symbol of the boundless opportunities that lay ahead. News of China's far-off triumph on the lunar surface spread quickly throughout the international scientific community, igniting a flurry of theories, from thoughtful academic debates to the most outlandish conspiracy speculations. Western scientists largely applauded China's engineering achievements and its steadfast quest for new data. Even though the National Aeronautics and Space Administration, bound by United States legislation, could not collaborate officially with China, there was still an exchange of some lunar findings and messages of congratulations. Researchers around the world awaited eagerly for Chang'e 4's geological discoveries, and some began to contemplate the possibility of working together through neutral third parties. Humanity's collective understanding of the moon grew with the successful landing on its far side. Could China be poised to uncover untapped resources or deploy observatories shielded from the noise of Earth? These kinds of questions fueled spirited conversations at scientific conferences and in governmental circles alike. At the same time, the mission's tight-lipped approach and the enigmatic nature of the moon's hidden hemisphere gave rise to rampant speculation. Conspiracy theories flourished across internet platforms and tabloid stories. Some theorized that Chang'e 4 had uncovered something remarkable, perhaps signs of extraterrestrial artifacts or ancient lunar structures shrouded from terrestrial eyes. When initial reports hinted at the discovery of a gel-like substance before any visuals had been made public, commentators speculated about everything from living organisms to secret outposts. A similar wave of excitement unfolded in the year 2021 when U-22 spotted a cube-shaped outline on the horizon, soon dubbed the Mystery Hut. For several weeks, online communities buzzed with playful banter and wild theories, suggesting the rover had stumbled upon a monolith or an alien dwelling. The rover team embraced the moniker Mystery House, but refrained from making any sensational pronouncements. As U-22 crept closer over numerous lunar days, it became obvious that the so-called hut was nothing more than a peculiarly shaped boulder perched beside a crater. In a charming twist, its silhouette resembled a crouched rabbit, an appropriate image since U2 translates to jade rabbit.
Beyond extraterrestrial musings, more grounded and strategic analyses have also emerged. Observers have noted the military connections within China's space initiatives, sparking concerns about covert intentions on the far side of the moon. Some speculate that a base could conceal operations or even function as an outpost for surveillance or missile launch detection hidden from Earth's gaze. Yet, there is no substantiated evidence that Chang'e 4 transported anything except scientific devices. The full payload was publicly disclosed and featured contributions from European partners, including a neutron detector from Sweden and a radiation measuring instrument from Germany.
Despite this transparency, the timing and objectives of China's efforts, especially as the United States and other nations renew their lunar ambitions, fuel discussion of a new space race. It is now clear that the revelations from the moon's hidden hemisphere are driving the evolution of future space policies, not only for China, but for all nations with their sights set beyond our planet. The findings and experiences of the Chang'e missions have given rise to several pivotal consequences. At the forefront is the very real prospect of establishing a lunar research station. The program's achievements have swung open the door for constructing a scientific outpost on the moon, possibly on its far side. Should people settle there, they would gain unparalleled radio silence for astronomical observation, enabling them to listen to the cosmos without interference from Earth. Yet, this advantage also comes at a cost. The far side's perpetual separation means constant communication challenges. Looking ahead, future lunar outposts will almost certainly rely on relay satellites similar to the QKIO to maintain communication. China has unveiled plans to construct a robotic research base within this decade, possibly employing three-dimensional printing technology to shape structures using lunar regolith. The far side of the moon, once an unreachable enigma, is now within reach, paving the way for habitats or observatories in places eternally concealed from Earth's view. Moreover, verified reserves of helium-3 and the discovery of other valuable minerals are fueling the prospect of lunar mining. If helium-3 can be harvested in meaningful amounts, it could trigger a revolution in Earth's energy landscape. Chinese researchers have calculated that 1 million tons of helium-3 from the lunar surface might fulfill Earth's energy demands for 10,000 years, essentially resolving the planet's energy and climate crises. While this projection remains somewhat speculative and realization is likely several decades in the future, the competition for helium-3 has already become a key element in global strategy. The first country to master efficient lunar resource extraction will secure a tremendous energy advantage.
Zhongguo lunar expeditions are laying essential groundwork to evaluate the feasibility of mining, running experiments to identify the best techniques for heating lunar soil and releasing helium-3. Not surprisingly, organizations such as the Atomic Energy Authority are backing China's lunar program. The moon could soon rival the Persian Gulf as the 21st century's premier energy frontier. Although most missions have so far touched down far from the poles, their findings are closely linked to the larger quest for water ice.
In recent years, multiple missions, including NASA's LaCrosse and India's Chandrayaan-1, have confirmed the presence of water in the moon's shadowed craters, particularly in the polar regions. Water is priceless. It can sustain astronauts and be split into hydrogen and oxygen for rocket propellant. This has not gone unnoticed by China's leadership. Upcoming landers are destined for the poles to further investigate ice deposits. Soil samples brought back by Chang'e 5 even revealed hydroxyl water bound within lunar minerals across mid-latitudes, suggesting that the solar wind implants water molecules into the surface. With both water and sunlight to generate energy, the vision of a lasting lunar settlement edges closer to reality. China's plans call for the direct use of indigenous lunar resources, allowing explorers, human or robotic, to excavate ice, melt it for drinking water, and process it into life-sustaining oxygen and hydrogen fuel. On the far side, especially in the South Pole Aitken Basin, scientists suspect that permanent shadow may harbor significant ice deposits. Should these be found, the decision to explore the far side may yield the secret to sustainable living off Earth. Ultimately, the China National Space Administration has mapped out a pathway where the Chang'e missions set the stage for an international lunar research station staffed by a crew in the 2030s. The plan envisions building a base, likely near the moon's southern pole, in collaboration with other nations. However, one critical issue lingers. Who truly owns the moon's resources? For now, the 1967 Outer Space Treaty forbids any nation from claiming sovereignty over the moon. But as extraction looms, new treaties or disputes may soon emerge. The country that leads in finding and utilizing lunar materials will shape the rules for everyone else.
The moon now stands as the main battleground for the 21st century space race, unfolding before our eyes. Following the Chang'e 4 mission, all major contenders accelerated their lunar initiatives. China continues to press its advantage with a deliberate series of missions.
In 2020, a new generation spacecraft brought back samples from the near side of the moon, including the youngest lunar rocks discovered to date, estimated to be 2 billion years old. Then, in 2024, Chang'e 6 launched and gathered the very first samples from the far side, drilling into the surface and returning roughly 4.5 pounds of lunar material to Earth. These samples are now under close examination, holding the promise of revealing new secrets about the moon's past and confirming earlier mission data.
Looking ahead, the 7th and 8th generations of lunar spacecraft are scheduled to launch toward the close of the 2020s, with their sights set on the moon's southern polar regions. Their mission will be twofold: to advance exploration efforts and potentially lay the groundwork for the ILRS Lunabase infrastructure. Chang'e 7 intends to search for water ice and analyze the unique polar environment, employing a combination of a lander, a rover, and a nimble hopping probe to investigate the craters. Meanwhile, Chang'e 8 is set to test innovative techniques such as utilizing resources found directly on the moon, signaling the possible initial stages of constructing a permanent outpost.
As the early 2030s approach, China aspires to establish the core of a research station at the moon's southern pole, inviting international collaborators who are willing to operate independently from the United States-led initiatives. At the same time, the United States has reignited its lunar ambitions through NASA's Artemis program, which is bolstered by private companies including SpaceX and Blue Origin, along with the coalition of allied nations. Artemis aims to restore an American human presence on the lunar surface and to secure a lasting foothold near the moon's south pole. Unofficially, the race begins with the first human landing of this new era. Initially planned for 2024, NASA's Artemis 3, the first mission intended to deliver astronauts to the moon, has been postponed to 2025 and possibly later. In reality, the anticipated landing is likely to occur around 2027.
China, in response, has publicized its intention to send taikonauts to the lunar surface by 2030, developing a new heavy lift vehicle, the Long March 10, complete with a lunar shovel. These schedules are ambitious, and it is evident that a subtle contest has emerged. In 2024, for the first time, Chinese officials described the United States as a direct rival in the renewed lunar race, a remarkable acknowledgement. A strategic forecast by CNSA predicts that within the next 20 to 30 years, both China's ILRS and America's Artemis base will be operating side by side at the moon's southern pole. The literal battleground is the same, sunlit peaks towering above shadowed craters rich in water ice, an area coveted by both nations as they seek to establish their presence and infrastructure.
This convergence is almost certain to generate geopolitical friction. The United States has formalized the Artemis Accords, a diplomatic framework outlining space resource utilization and conduct signed by a multitude of nations, whereas China and Russia are mapping out their own approach for the ILRS. Concerns have arisen over a potential scramble, not for territory in the traditional sense, but for access to strategic sites. Both parties are eager to claim areas offering uninterrupted sunlight for solar power and proximity to ice reserves. The question of whose regulations will ultimately prevail remains open.
Today's scenario is not the breakneck contest of the 1960s, but a much more intricate interplay of collaboration and competition. Legally, NASA and CNSA are forbidden from working directly together, yet overlapping spheres such as Europe, participating in both Chang'e missions and Artemis, have woven a network of indirect cooperation. Even so, the overarching trend is unmistakable. The space race has returned, with the moon now positioned as the prize for enduring exploration and, perhaps, future utilization.
In the 1960s, the lunar race was driven by the desire to outpace adversaries and leave a historic mark. By the 2020s, the objective has shifted to creating a foundation for generations to come. Ultimately, the pivotal question is whether these discoveries will inspire unity for the common good or ignite a rivalry that divides the lunar frontier. For now, the moon's far side is no longer shrouded in mystery. It stands as the testing ground for a new age, as nations and private enterprises alike turn their gaze to its surface, viewing it as the next frontier. Quietly, the secrets with the potential to shape Earth's destiny await discovery on the silver globe above.